Hey guys, how are you? Welcome to this video. This is the internal assessment in NCEA Level 3, which is on Conic Sections, okay? And it is three credits. It is internally assessed in schools. So this is just a practice paper, and the title is car logo. So maybe you have done this paper in school, but let's just get into this video. Okay, so just pause the video and then just read through the question and then we can come right back. Alright, so it says that from here, right, to here, it's 16 centimeters wide. Okay? And then it says that from top to here, it's 8 centimeters tall. And then it says that the central ellipse, which is this one, to here, it's 6 centimeters wide. Alright, and then it says the outer ellipse is 2 centimeters wide. Okay, so we have basically just drawn these lengths onto there. Now it says in order to make an accurate sketch, the designer needs to find equations that model each of the ellipses which make up the design. Alright, we have to find the equations. Let's start with the biggest ellipse because yeah, why not? So we know, let's put down the features we already know. So center is, we are going to make the center here, which is 0, 0. Okay. You can decide where you want to put the center, and I think I would like it to be 0, 0. The major axis, the major axis is like 2A, which is 16 centimeters. And then if we just isolate it, then it's just 8 centimeters. So remember the major axis is like the biggest axis, which is like this, or which is like this for this ellipse. And the minor axis is this way. And then let's scroll down a bit, too much. So minor to b equals to, that is 8. So 8, okay, so b is 4. That's our b value. And remember this equation, it's x squared over a squared plus y squared over b squared equals to, it always equals to 1. And then we just plug in the a and b values, right? A is 8, so if we square 8, it's 64 plus b squared is 4 squared is 16 equals to 1. And of course our center is 0, 0, so we just leave x squared and y squared as it is for this one. Yeah, that's the equation for the ellipse. Oh, we also have to list down the properties for, so we have to also find the foci. So um we would just, foci is equal to a squared minus b squared. Therefore a squared is 64 minus 16, and then therefore C is actually equals to, yeah, plus minus 6.93. So how we are going to write this is foci, right, is 6.93 and negative 6.93, and the y is 0. So the foci is around, if this is the center, right? So if this is the center and this is A, okay, this is negative A actually, and this is A, right? The foci is anywhere between this space, could be anywhere. Like it could be here, C, right? So we by using this formula, we are just finding that foci where about it is. Okay, so now we have to find the middle ellipse. So the center is 0, 0. Okay, so because the center here, we are making it 0, 0. Okay, so we can decide that. Now, to find the major axes, here it is a different situation. Okay, so you know how major axis is? Usually this is the major axis, this is the minor axis. In this case, it's like this. So our major axis is now this, because this is the major means like bigger, right? So this is the major, this is the minor axis. So major axis is usually 2A, minor is 2B. Okay? But in this case, since major is this, right? We are going to make our 2A equal to 8. You see what I did? It's the vertical now, not horizontal. We're not putting 6 on 2A. We're putting 8 on 2A, okay? Therefore, A is 4. And since our B has been 2B is 6 now, B would be 3. I hope that makes sense. So our equation, therefore, would be x squared over. Okay, so we also have to make some adjustments on our formula. So b squared will be underneath x squared, like I've written it down, and then a squared would be under y squared, just like how I have written it down. So now this all equals to 1. So it would be x squared over 3 squared is 9, because I'm getting this 3 squared from b here, okay? Plus y squared over a squared is 16 equals 1. Okay, now, now let's add the foci. So foci is equals to c squared equals a squared minus b squared. Therefore, c squared is equal to plus minus a squared is 16 and b squared is 9. Therefore, plus minus 7. So that is the answer for this. I'll just put it into coordinate form. So here we go. This is our foci in coordinate form. And now let's move on to the next equation. Okay, so now we have worked out the outer ellipse and this middle ellipse. Now it's time to work out what is the right, the small ellipse here, and this ellipse here. So let's work out the right ellipse first, like on the right. So the center for this is actually not going to be 0, 0, right? If you think about it, it's actually going to be shifted because it is actually going to be in here. So the whole thing is 6, right? For this middle ellipse, right? So if you go 3 this side, you go on the edge of this, right? And then since the whole ellipse thing is this is 2, the half of this would be 1. So we move 3 units, 1, 2, 3, right? And then 4 to the middle of this ellipse. So the center would be shifted 4, so the coordinates should be 4, 0. Now the major axis is, the major axis we do not actually know. We cannot know it because if you see it, this was A, but if you draw a straight line, there's like a little bit gap in here, and we actually do not know this point. So we only know the minor axis, which is 2b. So we know 2b equals 8. No, sorry. 2b equals 2 and b equals 1. So with the information we have right now, this is what we have. So the ellipse equation, since it is shifted to the right 4 units, it is going to be x minus 4 squared over b squared, right? Plus y squared over a squared equals to 1. Okay, so x squared minus 4 squared, or since we know the b is 1 squared, which is 1, plus y squared over a squared. Now a squared we do not know, so we're going to leave it like that. We are going to work this out by substituting 4 into the equation, the ellipse equation, the bigger ellipse equation. We substitute in the bigger ellipse equation, and this is going to, the bigger ellipse equation has 6, 4 plus y equals to 16 equals 1. So what we want is, we want this point over here. So we know this point is x equals to 4, okay? But what we do not know is what is y, okay? We do not know how high from here it is. So, x equals to 4. So 4 squared over 16 plus y squared over 16. Oh, sorry, 64, yeah, equals 1. And then you bring 1 minus 4 squared over 16 is 1 over 4. Yeah, it is 1 over 4. And y squared over 16 is left here. And let's simplify. 1 minus 1 over 4. We get 3 over 4. And then we bring it to the other side, the 16, to the other side. Y squared is left here. And then it is the square root of 12, which is what y equals. What this plus minus 12 is It's just saying that when x is equal to 4, which is on this line, right? Y is equal to two places, here and here. So these two places. So below the axis is negative 12, negative square root of 12, and above is positive square root of 12. I hope that makes sense. So therefore, our a value equals the major axis square root of 12. So now we substitute this into our ellipse, the right side ellipse equation. X minus 4 squared over our b value was 1, y was y squared over, and 12, and since it's a squared, squared, these both cancel out. Therefore, we simplify this to just 12. Okay, so now we have this was the right side ellipse, right? Now let's find the left side ellipse. So it's not that difficult, it's very similar. So for the left side ellipse, the center, we have to keep in mind the center is now negative 4, 0. Okay. Now our a value is square root of 12. Because we know this, because since we found this up to here, right? Since this is a symmetrical shape, this should also be square root of 12. So this is true, and then b is 1. So if we plug this into our formula, x plus 4, now this is the difference, over 1 plus y squared over 12. So in the end, it's very, very similar, but this thing is just swapped. Like, that's literally it. Like, if you get a symmetrical shape, it's usually the coordinates that's like swapped, but other than that, it's pretty similar. I haven't done the foci for either of them. For this particular question, you didn't actually need to do it. I was just doing it so, yeah, I was just doing it so like you kind of know what you're doing. So I wouldn't actually go into it, just gonna make the video way longer. Okay, so question number 2. Just read the questions and then we can go over it. Hopefully you have paused the video and read it, and so I've just pasted this here so like easier for us. A bigger picture is better. Okay, so we have to find the equation of this hyperbola, okay? And we also have to find the 4 vertices. So we have to find the 4 vertices of this design. So that's one point, that's another, that's the other, and this. So we have to find these 4 coordinates. So they tell us that this is the asymptote. Okay, let's just see what we know to get us started. So we know a value is 8. 2a is 8, right? Therefore 4 is the a value. Okay, so how do we know this? We know this because of this. The minimum width of the design is 8. So from here to here is the minimum width. Okay? Which is 8 cm. That's great. We worked that out, okay? Now it says asymptotes. Asymptote is plus or minus 1 over 2. Okay? So there's a formula which says asymptote is y equal to plus minus bx over a. So therefore, if a equal to 4, right? Then y plus minus bx over a is 4. So b should be 2x over a over 4. Because we know the asymptote, because we know that a is twice of b, okay? So that's why we know that this is the asymptote. So now we know the b value, okay? Okay, so we know that a equals plus or minus 4 and b equals plus or minus 2. The equation of the hyperbola x squared over a squared minus y squared over b squared equals to 1. Very similar to ellipse, but only that there's this minus sign in the ellipse formula instead of a plus. So therefore, this should equal x squared over a squared is 16 minus y squared over, yeah, that's 4. And we to find, that's the equation, right? But to find the vertices, we want to substitute this hyperbolic equation into it's like a simultaneous equation. We have to substitute something like y squared, let's say, into the ellipse equation to find the intersections. So to do that, we want to make, so what we can do is make the denominator on this side the same. We multiply this by 4, multiply this by 4. Okay, this should give us x squared over 16 minus 4y squared over 16 equals 1. So this is basically like this. We can multiply 16 to the other side, right? This will leave us with x squared minus 4y squared equals to 16 multiplied by 1 is 16. And then we can bring, except x squared, everything to the other side. So 16 plus 4y squared. And this is what we're going to substitute into the big ellipse equation. So x squared equals 16 plus 4y squared. So the equation of the ellipse is x squared over 64 plus y squared over 16 equals to 1. and then we can just substitute this directly to that. But to be honest, it's better to remove this fraction, right? So we're kind of going to do the same thing as we did there. Okay, so we're going to multiply this by 4, multiply this by 4. Okay, therefore this should give us 4y squared over 64, and x squared plus 4y equals 64. So now that's our ellipse equation without the fraction. And now it's time to substitute. Now sub in that equation. So x squared is 16 plus 4y squared. We are bringing this from here. Okay? And now we bring in this equation plus 4y squared equals 64. This becomes 8y squared, and 64 equal to 64 minus 16. 48 over 8 y squared, and this should give us square root of 48 over 8. 48 over 8 is 6. Square root of 6 is, it's plus or minus square root of 6 is we can just leave it like that. We don't need to. Yeah, so y is equal to square root plus or minus square root of 6. Wait, before we go into, oh yeah, actually never mind. So we have this we have what is y. Okay, now let's substitute back into the hyperbolic equation. 15 plus 4 plus or minus 6 squared. This is just going to come out with a positive, so the negative actually does not matter. Let me just go straight to the answer actually. So x is therefore equal to plus or minus 6.32. We have the 4 points. Okay, so the 4 points is, now we are making negative 6.32 with positive 6. Actually, wait, let me just get the picture. Okay, so this point is here. So this is, so the y, no, so so the x-axis is negative 6.32. Y-axis is 6. Okay. Our next point is positive 6.32 and 6, which is here. Positive 6.32 is like 0.32, 6. Okay. Our next point is negative 6.32 and negative 6, which is going to be here. Negative 6.32 and negative 6. And our fourth point is positive 6.32 and negative 6. Hopefully this made sense. So this is, I think this is merit, right? Because it was quite a bit of working here. Okay, so question 2 is finished. Now let's go into question number 3, and it is for excellence. So hopefully I can explain this. Whoa, a lot of work. Okay, so just read through the questions and we'll go over it. So I have made it a bit smaller. Okay, so they again mention the hyperbola asymptotes as that. Okay, so they actually tell us the height of the logo, right? And this is 2p, okay? And then they also mention that this is also 2p because the minimum width of the logo, which is actually from here to here, is always equal to the height. I know this diagram I drew, it's not on scale. And then they say the width of the ellipse is from here to here is 4p. Very bad drawing. Let me make it again. Ooh, this arrow is... I should have used this a lot. Let me use it here as well. Uh-oh. That's 2p. Okay, and this thing, the width of the ellipse is 4p because it's twice the height. And now let's find the coordinates. We have to find... I think we have to find this. No. We have to find these coordinates. But first, let's find the equations of the ellipse and the hyperbola. Let's start off with the ellipse equation, and this is, we will make our center 0 0. Okay, our a value will be 2a. So our major axis is this. Okay, that is 4p. Our major axis is 4p, therefore a is 2p. I hope that made sense. And our b value is 2b equals to 2p. Okay, therefore p is actually equal to p. So our ellipse equation will be 2a. Our major axis is a. Okay, so that's why a is going underneath here. And then y squared over b squared equals 1. So our x is 2p squared. I'm not going to rewrite it, I'm just gonna do it. Okay, therefore 2 squared is 4, p squared is p squared. Okay, so y squared over b is p, so it's just p and then squared. So this equals to 1. So that's our ellipse equation. Now we have to find the hyperbola equation. Just going to draw a line. Okay, so hyperbola. We know that y is equal to bx over a. Our asymptote is plus minus 1 over 2. So therefore we know that we know our a value. A is sorry. A is actually p. So since A is twice of B, right? Therefore A equals to B, sorry. And therefore this should be 0.5 P to make this even, right? Does that make sense? So therefore 0.5 px. So this is the asymptote, right? Over p. So a equals p and b is 0.5 p. Now let's substitute that into the hyperbola formula. And that formula is x squared over a squared minus, remember that minus sign in the hyperbolic formula, because that's the only difference between the hyperbolic formula and ellipse formula. So a is p and b is the 0.5 p. Oh wait, and yeah, it's squared, so p squared. The 0.5 squared is 0.25 squared. Oh, sorry, 0.25 and p squared, yeah, equals to 1. So what we can do is make the denominator the same, because this is very similar to the last question, question 2, because we want to find these vertices. So we want to substitute the hyperbola formula into the ellipse formula. So it's better to make it so like there is no fraction, so we can substitute it. It's just going to make it way easier. So x squared over p squared minus 4y squared over p squared. How did we do this? Okay, so we just multiplied the whole fraction by 4, right? Okay, so equals to 1. Therefore, x minus 4y squared is p squared. And we can isolate the x. Sorry, I forgot the squared. Equal to 4p squared plus 4y squared. So let's go. Okay, so what was the equation of the ellipse? It was around, I think, squared over 4p squared plus y squared over p squared equals to 1. Yeah, okay. So we can remove the fraction, but just to show you guys, I'm just going to keep the fraction, that it still works, okay? So p squared plus 4y squared. Remember, we're just substituting p squared plus 4y squared in x squared, okay? Over 4p squared plus y squared over p squared equals to 1. Okay, now we have to remove the fraction. What we can do is multiply this side by 4, top by 4 as well. So it will equal 4 plus 4p squared. Since the denominator is the same now, plus 4y squared equals to 1. And then we bring the 4p over the other side. P squared plus 4y squared plus 4y squared. Okay. We can remove the brackets actually. This will become 8y squared, and then we can bring the p over the other side. This will 4p squared minus p squared is 3p squared. Therefore, yeah, we wanna isolate 8, right? So 3p squared over 8, that's y squared, and then y equal to the square root plus minus the square root 3 over 8p squared. Okay, so that's y, but we can also simplify this as plus minus, like in a decimal simplification, I mean, 0.375, and then out of the square root p Okay, so that's y. Now let's substitute this y into this equation. Okay, so x squared is p squared plus 4 plus or minus 3/8 p. This will mean the p squared will come like this, okay, and be like 3/8 because the square root and they cancel out. Therefore, if we simplify it further, we get 1.5 p squared, okay, therefore 2.5 p squared square rooted. This will mean, oh, plus minus actually, right? Plus minus 2.5 p. Or we can also write this as x equals to 5/2. Let's just write it at p squared, man. It's just better. Yeah, so let's bring in the diagram of the, where is it? Oh yeah. So so our first point would be negative 5/2 p squared. Okay, and then we get the y as positive 3/8 p squared. Yep. So that goes over here. Okay, our next point is negative 5/2, same thing, same x value, but it's negative 3/8. That is this point right here. And our third point is yep, positive 3/8 p squared. That point goes over here. And our last final point to get the excellence is 5/2 p squared minus negative 3/8 p squared, and that's your excellence. Okay. So that is that was the whole working. That was a lot. Now, did we answer the question? Yes, we did, because we had to give the coordinates, so like we did give the coordinates. So that's the video for today. I hope this actually made sense. This is probably my second video making NCEA past papers. It's probably not that great, but I hope I can improve in the future. If you guys like this video, please comment, like the video, and if there's any improvement I should do, please also comment so I can improve in the future. Thank you for watching the video. See you.